I would like to spend some time with an introduction of myself, and the matter that we're going to discuss is a bit broad. It would be about how to calculate footprint in an industrial and in a private situation. So we'll deal with both. And we'll also ask ourselves how to reduce footprints. And we'll need to talk a little about boundary conditions, which are in essence legal boundary conditions. To begin with, I'll introduce myself in a couple of slides, at least with respect to what I'm doing. Are you aware of what the context of this here is? Apparently a sustainability-related discussion. Are you all acquainted with the term sustainability? Is that clear? I would still like to express a couple of moments on that, because I often find sustainability is a bit of a misused term. At least it offers to be misused. There is a rather old definition of von Karlowitz. He was a German guy, actually, and he was a man acquainted with forestry. He was traveling through Europe in the late 1600s and early 1700s and summarized what he has seen in essence in France, in Great Britain, in Belgium, and in Italy, with respect to what we today call sustainability. So it's not that he invented the idea of sustainability, however, he phrased it as sustainable. And there's at least one rather famous quote, and that's this one here, out of his book, which in essence deals with how to raise forests. And that it's focused on conservation and cultivation of wood, so that there is a continuous, sustainable, and lasting supply. A lesser often phrase of his work is that, and I like it actually more, is you shouldn't throw away clothes prior to buying new ones. The idea is use your resources as long as you potentially can. Interestingly enough, at least in my opinion, is the fact that, have you heard about what life cycle assessments is, or the term life cycle? Okay, between the lines, this here and the other quote that I was giving also introduced the term of a life cycle, because usually a life cycle is split into harvesting materials, growing materials first, harvesting material, using them for production, utilization of the product that is resulting, and either disposal or reuse. Now here clearly he introduced use, and he introduced the idea of harvesting and growing the resources. So there was somehow a mindset that is very similar to what we have today. However, we should not mix the fact up that this is not the first time in history that sustainability or sustainable use, in the sense of caring for the environment or caring for humans, was addressed in history. We have had a legal regulation, for example, in London in the 1100s, in which locksmiths were prohibited under certain weather conditions to use their fire, because the smoke would harm in the fog, would harm the respiratory environment of humans. So you wouldn't want smoke to enter fog. Consequently, certain activities were prohibited. And that is very old already. So this is not, by all means, it's not new. So we should be aware that the idea of sustainability is a rather new one, in the sense of it refers to life cycles. And if I'll introduce two other definitions. The one on the very left you will have heard of is the definition that was used in the Brundtland report in the late 1980s. Are you acquainted with the Brundtland report? Yes, no, no, yes. Some are, some not. Gro Harlem Brundtland, the former Danish, I think it's Danish Prime Minister, was appointed by the United Nations to head a committee which had to look into the future and what hinders our future to be prospering. And that was based on the study of the Club of Rome in 1972 and 1973. So in 1972 and 1973, there was this study on that led to the insight that the Earth will no longer survive because of limited resources. The United Nations took up that impulse, invested in the Brundtland Commission, and the Brundtland Commission's activity later on resulted in the Rio contracts in 1992. So the Brundtland report again started with the definition of meeting our own needs without compromising the needs of subsequent generations. So we would like to survive ourselves, however, our children should also have the right and the option to survive. That was the essence of the idea. Now, both of those approaches, both this one and the one on the very left, von Karlowitz and Brundtland, as well as other definitions, in essence focused around humans. They focused around us as a species. However, our current understanding should be that we will talk about the sustainability or the survival of all species. We understand today that we are living in an ecologic context which should allow other species also to survive. That was addressed, and this is the University of Alberta, which by a definition of the University of Alberta, which regards sustainability rather as a process which permits all species to survive. Now this is rather up to date, and only the middle one is focusing on nature as a broadened system, not as a perspective that is only geared towards humans. It's not the intent of this definition. And I found it remarkable that there's only this one I found. Still, all of them have this thought in it that nature as such is sustainable, which I find kind of astonishing, because if you would be a dinosaur, clearly you wouldn't exist anymore. And out of the perspective of a dinosaur, nature is not sustainable because it doesn't offer a place for you. So the thinking that sustainability refers to a constant setting rather than a time-dependent setting is not included in either of those. So be alert, sustainability is very much, in our mindset, very much focused on humans. And even if it's not focused on humans but on species, it assumes constant boundary conditions, and those are not there. So there is a misunderstanding somewhere here, and I could spend about 2 hours only on that slide. And it's particularly fascinating that all of us don't seem to operate in this direction. Anyhow, with this definition, in the mid-90s, beginning 2000, plus minus time frame, there was a general understanding that the thought of sustainability would have an effect on companies, in the sense of, if a company harms what we regard as sustainable, whatever that is, that could limit the amount of money that it can earn, or it could harm the value that this company has. This is nowhere to be seen here, but the implicit message is rather clear. If you don't act sustainable, your company has no opportunity to survive. And that leads to a need that was first accepted in the, I think, 2002, 3, 4, something in that arena. Maybe it was also prior to 2000, but it's somewhere around there. We started to see sustainability reports which came from individual industries. So a company would say, well, I act responsible. As a consequence, I'm doing this. The message is not that I'm acting responsible as a company. However, the message is that you are investing into myself, you are, and you would like to hear that I will survive long term, while the other one who does not act in this direction will not survive. So the story about environmental or sustainability reports was in essence based on the idea of value persistence, of constant values, of rising values. So today, and we'll talk about this in a second, what we regard as non-financial reports, and companies are by law, and will be over the upcoming 5 or 6 years, you will see all of this non-financial reports, is in essence driven by a definition which was originating of a very social, ecologic, governance-driven idea. I'm going to have a company with a constant value or a growing value, which in essence is not hurt by environmental effects, by social effects, and therefore is sustainable. So, a bit of a weird definition. I'm sorry. Now, today, companies have to write a non-financial reports, and there is no standard yet. The standard is in the process of being written. It's the European standard on environmental sustainability report of the, that was Bavarian and you're not going to translate that. I mix up the abbreviation right now. European Standard Reporting System. I missed it. Anyhow, I somehow don't get it. There is a standard structure already available, and that refers to general information, environmental information, social aspects, and governance. In the environmental aspects, you see CO2 footprints, social aspects, for example, human rights, governance, risk assessment. All of that are part of the non-financial reporting. The legal regulation would be the taxonomy directive of the EU and the non-financial reporting directive. So that's if you want to look that up. Now these reports are written within a company, and then these informations are analyzed, assessed by the CEO, and then if he agrees, then these are newly phrased so that they are possible to be sold to the environment. The internal reports are contain company proprietary information. The external reports are meant to be seen by the stakeholders, and stakeholders could be yourself as owners, could be the workers' representation, could be others. There is an external reviewer, and he says everything there, everything rightly informed. The external review could be tax reviewer, could also be Deloitte, for example. There are internal measures, and then for some companies, those environmental reports are passed on to external evaluators. For the very big companies, Though there are, on a worldwide scale, about 10 companies who do this type of evaluation. However, don't be misled. The taxonomy directive forces banks to assess your sustainability risk as a company in order to derive the interest rates that you pay when you want to get money. And that's particularly important. So when you write here that you run environmental risks with how your company operates, that has an immediate impact on your tax, on your credit rating. The credit rating will be worse depending on the degree of what are you risking. So this is about the kind of structure. My role in this context is, and that's what I usually do when I work, is I write an environmental report or the sustainability report, the non-financial report, for the internal use together with people working in the company, because I cannot do this myself. You need internal knowledge. Then we do the internal analysis and get the internal measures out of this. And then the CFO says yes or no. And then it's out of my hand. Then there is a PR department and a legal department involved, and they write the internal report, and the external report, and the non-financial report is equally important than the financial report. So that's what the taxonomy directive says, and the respective law in Germany is in place as of January 1 of this year for bigger companies. The plan is, however, that companies above a size of 250 employees have to write this type of report. And this will come within the next about 5 years, I guess. Don't be misled though. First, banks have to look at it anyways, independent of how large you are. They are forced to, so there is not a choice. A bank has to look into this aspect of your work. And the bank has to take value on it. And if you are part of an industrial value chain, even if you are smaller, you are forced to give such a report or you lose a client. I was at some moment consulting a company which delivered plastic pipes to Deutsche Telekom. Think of the situation. There's a company in Dubai having 40 employees, no clue about German legislation, just skip the idea. How should they know that? Most of the employees came from India. And they had to write an internal report for Deutsche Telekom on their carbon footprint and how they would like to develop this and all of this, and they didn't have any idea. So I was consulting them in order to help them to write this type of report. This is a situation in industrial value chains we will see very often in the near future, because the legal situation is so that the companies that are forced to report will get smaller and smaller. So we'll see that within the next 5 to 6 years. Again, that the areas I was graying is what I usually do. If you look to a report, and that looks kind of European Sustainability Reporting Standard. This is what ESRS is. I'm sorry for this. This is the structure. So you do have what is standardized. The ESRS 1 would be general information, strategy, governance related information, environmental information, social information, and governance information. So this is why often you see the abbreviation ESG reporting. This is what is contained. And for those of you who prefer German, when they Google, the DNK is the Deutsche Nachhaltigkeitsindex. And if you Google the Deutsche Nachhaltigkeitsindex, it's significantly easier to read than the English abbreviation. So it's just, this one is per bullet point between 50 and 100 pages. And this here in total, I would guess it's maybe in total maybe 100 or 150 pages. So it's way simpler to read, way simpler to understand. So what we speak about today, and this is why I'm trying to make that point, is only this aspect here referring to climate-relevant emissions. So this is the only point. However, when I write a report, there is significantly more to talk about. So this is why I'm trying to make this difference. Again, if you looked at the DNK, Deutsche Nachhaltigkeitsindex, that would be particularly helpful for at least the German readers. Sorry for you, can't do anything about it. Okay, so with this introduction, now you know about what I'm doing, and maybe to add a little on myself, I hold a PhD in physics, and I teach part-time at University of Grenoble, and have been working in different management functions for a number of decades at research environments or at Canon. You know the camera vendor Canon, they also produce printers, and I was in their printing environment for several years. Anyhow, so the structure of what I would like to talk about, could you give me an alert maybe 5 minutes prior to where I needed to stop, because I don't have a watch with me. So I would like to talk first about how to calculate footprints, then give you an idea about errors, give you examples, and then speak a little about eco-design and pick one example, which would be a digital newspaper, which we could later on also discuss, then talk about personal footprints, and then kind of summarize. Now, how do you calculate footprints? There are two relevant approaches. One is standardized, one is not standardized. The standardized one you find at the ISO 1441 and 1440 and the 1464/3. The upper one would describe how you do it. The lower one would describe, so that in the management sense, the lower one would describe how you calculate. So what do you need to do and how you calculate things. Be alert. Are you acquainted with the Sustainability Development Goals of the United Nations? Have you heard about this, the SDGs? So, okay, there is more than CO2. I already mentioned that. It's interesting to note that the CO2 emissions in this standard are not linked to all other SDGs. So you should always keep in mind, give you an example, if I speak about nuclear power, then taxonomy directive says nuclear power does not go along with CO2 emissions, and therefore I don't need to calculate those, which is kind of reasonable. However, in the respective sustainability report, there must be somehow a reading on land consumption, pollution due to uranium mining, and due to trying to get rid of the uranium that you have. The latter part is mostly not mentioned. So you should be aware of that we are talking about a subjection of a bigger context. That was that. Okay, so what does that, from a legal perspective, the ISO 14040 and the 1464 are referred to in the Product Environmental Footprint Guide of the European Union, and in the Organizational Environmental Footprint Guide. So you see the two of them refer to the ISO. So that would be the link between the legal situation and the standards world. Now, how is that being calculated? The idea of the standard is to split the emission into 3 subsections. One section would be what is emitted out of the company's activities by all sorts of energy or material consumption. Scope 1, I will stay a little vague on that, but you'll see in a minute why. Scope 2 would refer to energy in its different forms that a company buys, which on its path into your company would emit CO2. So you buy steam, you buy electric power. In Germany, about 50% of all electric power is somehow generated by coal. So there must be emissions going along with consuming electricity. And scope 3 would be split into two parts. One is the whole flux of materials and services into the company, and the one out of that company. When we speak about CO2 emissions, we sort of organize everything in terms of CO2. However, there are also other greenhouse gases which are translated by equivalence into CO2, and those could be the nitrous oxides, the organic, the alkanes, for example, organic gases, and so forth. So you have a number of gases, and this is why in numbers what you always see is the term CO2 equivalent, CO2 EQ. And that's why, so it's not all CO2 that is emitted. For example, if you have an old refrigerator and you throw it away, then there are so-called freons, certain gas types in there, and they have a significant environmental effect, which again is translated into CO2. Welche? Die drei. Scope 1, Scope 2, 3. Scope 1 ist im Wesentlichen, was innerhalb einer Firma an nicht mobilen oder an gar sind die Quellen, warten Sie, ich mache es anders. Sie haben innerhalb des Greenhouse, ich mache das, I'll repeat this in English in a second. Sie haben innerhalb des Greenhouse-Gas-Protokolls im Wesentlichen 3 Fragelisten mit etwa 40 Fragen. Und ich habe mir jetzt gespart, dass ich Ihnen alle 40 hier vorhechel. Aber die Idee ist einfach, Sie haben Scope 1 und dann haben Sie 4 Fragen, die dazu gestellt werden. Sie haben Direct Emissions from Combustion Processes in Stationary Immobile Plants. Sie haben einen Notstromgenerator. Der braucht Diesel. Sie haben ein Krankenhaus, Sie haben einen Notstromgenerator, um die Stromversorgung sicherzustellen. Okay? Wir haben Kühlanlagen, Volatile Gases. Die Frageliste. Scope 2 und so weiter. Sie kaufen Strom. Dieser Strom führt zu Emissionen. Sie kaufen, Sie haben Kühlung oder Heizung. Sie kaufen Dampf. Ach nee, Dampf ist hier. Sie kaufen jetzt eine andere Art von Heizung, Entschuldigung. Okay? Und Sie haben dann Scope 3, die eingehende Wertschöpfungskette und die ausgehende Wertschöpfungskette. Und Sie trennen beide nach Emissionen. I see you're making notes. Was that randomly clear or shall I repeat that?
No, it's clear, yeah.
Okay, good. Sorry for this. Ich danke, dass Sie fragen. Fragen Sie einfach. Wir dürfen uns Zeit nehmen, habe ich verstanden. Okay, we did have a pre-internal production situation, it's scope 3, and a post-internal production system. Give you an example. I'll use an example later, but maybe that's a good moment to display that. When we produce a newspaper, an analog, we produce a book, fine? So when I consume this book, I sit at home and I work under the assumption that consuming a book doesn't cost energy. So fine. So this, with respect to waste, would be 0. May not be 0, but with respect to energy, I skipped quite a number of phrases, questions. That would be 0. So I don't need any. When I produce a digital newspaper, I would have to use my computer. That would have to consume energy. I would access data from a server farm. So therefore, the post-production phase would go along with the consumption of energy. So this is why both situations have to be considered. There is a trick in this, and if you read CO2 reports by companies, maybe I should take a wider view on that. In most of products that go, most of physical products, dingliche Produkte im Deutschen, also things, most of those would have about 2/3 of their emissions in scope 3. Some of those companies that produce those state that they do CO2 reports. However, they don't report CO2 scope 3 related emissions. That's a trick quite some companies play, and you should be aware of that. So if you read over it and they state that, you can tell that they miss about 2/3 of their problem. Minimum, often more. Okay. Now there is a second approach to CO2 footprint. You should be aware of it's not standardized. However, that is a problem, and we'll talk about CO2 footprints in a minute in more detail, and then you see why that is needed. Think of the following situation. You are I always use plants because I have kind of fun with it. So you produce avocados in Turkey, in Italy, and in California. Clearly, those are different climates, but however, clearly you can produce avocados in these 3 regions. Now think of the following situation. You are in Turkey, you produce avocados, and you want to generate data on your CO2 footprint. And you don't have, you start with the assumption that an avocado starts its economic life cycle by falling from a tree. Now that's a stupid idea, but anyhow, that's how you could think. So what could you do is, you could sort of stumble into that problem, then ask yourself, well, I don't have any number that refers to growing a tree, fertilizing it, getting water on it, and da-da-da-da-da. So all of these stories, you would try to find literature on. So I could just miss the first part of the story and replace it by literature data and find those in literature, knowing that it is wrong. However, it's better than doing nothing. That is in essence the approach that is known. This is the economic input-output approach, and that often is also used with the term LCA, so the life cycle assessment. So if you Googled that, this is in essence the second method that is widely used, and it's used for estimation. So if you don't have a clue about certain things, look into literature. And then if you don't find literature, then that's a good way to identify numbers which are at least closer to the real world. However, they may not be precise. Another example, if you build a house, probably there are different numbers on that, but probably about 1/3 of the emissions that goes along with a house. So again, life cycle, I build a house, I use it, I abolish it, do whatever. So about 1/3 is spent only in building the house. So if I don't have numbers on that, assuming that the rest is 2/3 helps. I may be off 20%, but still it's better than nothing. So this is about the thinking that is here, right? So either I have precise numbers or I estimate using literature data. Now, what you do, did I miss one? Nope. What you usually do is, so you first build a model in this process. Model means which processes do I include, which processes do I not include. And that's a thinking process. You ask all the experts that you get knowledge from, and then you find out like, oh, this is important for us. And when you made something wrong, often you do something wrong, at least when you do it first time, then you do it better the next time. It's even standardized in ISO that this is an iterative process, so a process in which we learn as the process goes along. So we should be aware this is not solid science. For those of you who did physics or something in the past, that is not this type of science. So you learn as you grow. Then you get a balance sheet at the end of the day. And then you do two things. The first thing is you look into risks. And then when you look into risk, it's a rather simple process. You ask yourself, well, if I have a continuous process, for example, I have a newspaper and I'm forced no longer to use papers for whatever reason, or no longer to use certain inks for whatever reason, then this would go along with risks, and I would have to name those risks. Banks, in their evaluation of your sustainability situation, would have to look into the balance sheets and the risks that they have. For those of you who have fun with it, when you had older printing processes like old newspaper prints, they had an ink with toluene in there, and toluene is very close to benzol, and both of those are known to may cause cancer. Benzol is, toluene is in discussion still. So you don't want to use this kind of ink, bad news. So that would be named under the risk section. And that as a consequence, you would want to replace this type of ink with another type of ink. However, that may go along with a higher CO2 footprint. So that you have to balance that somehow, and lawmakers will support you in that process. Out of those two, the balance sheets and the risk, you develop strategies. You develop what you would like to do, because you don't do a footprint just for the fun of it. However, you want to do it in order to reduce it. You want to reduce the environmental impact, right? So now we're at the strategies, and the strategies lead to targets. The targets would either be made by the lawmaker, or the targets would be made by yourself as a company. And then you would manage actions as you usually do in a management process. From a target point of view, you're all aware of the Green Deal of the EU. You've heard about this. So the Green Deal of the EU says that we would need to reduce our CO2 footprint by a certain percentage by the year 2035 and by the year 2040. Now that you can translate into how much you can reduce and have to reduce your footprint annually. That doesn't require a PhD. If you reduce your footprint for about 55% within 10 years, logically you need to reduce it by 5.5% per year. Otherwise there's no way to reach the target, unless you have a smarter strategy to just do it in a non-linear way. But the minimum you can do is follow 5.5%. The UN says that the CO2 footprint should be reduced by about 7% per year. And that is because some of I'm trying to avoid the term third world countries because I hate it, but speak about countries of the global south. However, those countries are not of the global south. Anyhow, you use some words. Some countries are not making their targets, and therefore the EU target is somewhat below to what is required on a worldwide scale. The scientist-based target initiative only speaks about 2% of annual reduction. What I want to say is these targets here are negotiable depending on whom you talk to, but the approach in general is not. So you have a balance sheet, you reduce your footprint by a certain target number per year. And that, of course, determines your measures. It's rather obvious if you think about it. Okay? Now, so far that looked rather simple, I think. Now, I'm trying to be a bit more unfriendly. So scope number 3.1, referring to your earlier questions, would be purchase goods and services. So this would be the kind of list that you go through, like this is the question that you have in your hands. Now, we are looking at paper. Now, when we are looking at paper, and we take an example of a newspaper. Pick any example, any other example, story would just go the same. I picked just the newspaper because I do have some numbers on that. So I go for that, and then what the suppliers, the paper mills, give you are what is called conversion factors. So a conversion factor in essence is a number that translates for this amount of paper, I consume this amount of CO2. So 1 ton of paper translates into energy consumption of X tons CO2, right? Now, in this particular case, newspaper, there are 3 paper mills. One delivers this, others this, and so on and so forth. However, the 2 of those give significantly different conversion factors. And the obvious question is, who's right? Because you give me this one for your paper. I produce my newspaper so that it looks the same whether the paper comes from you or from you. So there should be some kind of difference. And bad news, in this case, this paper mill is located in Germany and this here in France. In France, they use electric energy for drying, Germany too. However, the carbon footprint, because of the taxonomy directive, is only 1/3 of what it is in Germany because of nuclear power being used here as opposed to other energy being used in Germany. You look as if you had a question. Okay. This paper mill was located in Switzerland, but it's not important because it's only 23 tons, so just skip the idea, independent of how large the number is. That sounds kind of ridiculous the way I present it. However, it's important to just set priorities, because if you could spend energy on this, but it wouldn't take you anywhere. Now, this difference here is rather interesting, because at the end of the day, we are doing this, A, to reduce our carbon footprint, and B, in order to send our reports to you 3 stakeholders. So if I reported the wrong number here, you could later on make me liable for a wrong number. Because when you say, well, this footprint, if this would be larger, I would have to have a higher credit rating, and if the credit rating would be higher, my company value would be lower. So it's important to realize that there is a legal impact behind that. So the head of the company, usually the CFO, who is responsible for reporting, has to consider that. So in this particular case, I was asking the paper mill, I was calling them and said, like, well, could I get a CO2 footprint report from your side and a sustainability report in general, because I would like to understand how you calculated and assembled data on your on sustainability-related impact due to uranium mining in your report. Now, are you coming from France? No, okay, good. So anyhow, I then ended up to call Électricité de France, which would be the electricity supplier, and they wouldn't give me a report on that. Even worse, that was in France, and you may have read reports that due to high temperatures, there were the rivers went rather low in France during last year's summer. That has as an impact that the nuclear power stations would have to be switched off in order to avoid overheating of the rivers. That has as an impact that France, Électricité de France, would have to buy electricity from abroad, which again was produced with coal. that must have an impact on that number. Sounds stupid, however, the reporting, the law goes that reporting is both retrospective, previous year, and prospective, next year. So if I know that, I could ask you as my electricity supplier, so what do you plan for next year? So, and what was your actual number last year? Because it cannot be this, because you couldn't predict how often you would have to switch off the nuclear power plants. This is a rather complex situation, so I'm trying to talk you through that in somewhat more detail to tell you that the questions are rather straightforward when you calculate the footprint. The answers are not. You need to go into details and prepare yourself for stupid discussions, because you enter a situation where neither you nor your discussion partner understands what he or she is talking about. They don't know, and you can't even claim that they are wrong. They simply don't know it. You cannot predict how hot the next year's summer will be. Even worse, those data are usually only available 2 or 3 years after this business year. However, the non-financial report has to be delivered by May 1st. It's by law. That means that those numbers are wrong. I don't know how wrong they are. I just know that they are. Sounds stupid, but from a reporting perspective, if a non-financial and a financial report have the same status, and the financial report has to be delivered after 3 months after the end of the business year, it's even 1 month longer than you have for the non-financial report. But you cannot deliver that 2 years afterwards. So from a legal perspective, I understand why that is the case. From a science perspective, it's a mess. It's a very complex situation. So this is why the prediction goes that over the upcoming years you will see rather often a situation in which someone says, well, you delivered the wrong report, which could be true. Or same situation, newspaper uses a press to print. Well, it doesn't require a PhD, it's simple. Now in this particular case, the press vendor went bankrupt in about 1998, 1999, something like this. At that moment, there was no one who already asked the question for a carbon footprint. A press usually has a lifetime of about 35 years. So the press exists, it operates, so you don't throw it away, clearly. It's a significant investment, so this is lots of money. So you ask yourself, well, where do I get my footprint from? There's no one I could ask because the vendor is bankrupt. Even if he would be there, I doubt that he would know. But in this case, there's just no one to talk to. So bad news. And then economic input-output approach, you just guess a number. You ask yourself, well, where could I, with magic witchcraft, could get a number from? So it sounds trivial, but it's an obvious problem. So what I did in this case was I thought about two situations. First was I estimated the amount of steel that is there. And for steel, I knew a carbon footprint, first. And second, I had access to data from a competitor who had a significantly smaller press. And then I calculated as if the throughput of the smaller place would go linear with the throughput of the larger press. Is that wrong? Yes. If you have a smarter idea, I'm happy. I didn't have one. Bad news. So I know I'm wrong, but this is rather typical for the economic input-output approach. You don't know what to do, and you're trying to invent something smart. You could be wrong. You could be right. Bad news. Either way is wrong, and you know. As a consequence, you make an error. And you should always be aware of the error that you produce and where that originates from, and be clear in communicating about that. Same story about waste. I had conversion, so I got this list But think about this, except of this column here. Now those would be actual numbers, so, and then all of a sudden there comes in a used electronic devices. Well, 120 kilograms. What's the carbon footprint of this? So, there's no way for you to know, for me not either. Or I had one, where was that? Fluorescent, oh, that was the fluorescent tubes, right. I didn't find numbers. Again, if someone has a better number, sludge, relatively typical. So those would be all muddy wasted that come out of a kitchen. I didn't find a carbon footprint for that. So bad news. So what I'm trying to get is you have rather precise questions and you end up with fuzzy answers because you don't get numbers. So you have an error on the responses you give to the carbon footprint questions. Same approach for ink. I found several different CO2 footprints for the ink. So one said 2.5 kilogram, one said 2.85, one said 1.8, should be, 1.85. The companies who produced those didn't disclose numbers. So they didn't want to talk about that. That, by the way, it's against intuition, and I wrote an article about that which caused quite some problems also to myself. When you paint something, the carbon footprint of the paint can be higher than the carbon footprint of the substrate. So be alert of that, that's non-trivial, because there's no way for you to tell up front what has a higher carbon footprint. It's the surface treatment or the substrate you print on or you paint. That goes along for all kind of coatings. Anyhow, so the next point I'd like to address, so now we know we run into problems by just answering the questions. Wie viel Zeit habe ich noch? Können Sie mal gucken, bitte?
So we have the room, I think, at least 1.5 hours. So we definitely have another 37 minutes.
Okay, good.
Probably more.
You just ask questions, right? So when we look into errors, I convinced you that I cannot avoid errors, and I simply don't know. I would wish to know better, but there are errors I cannot avoid, and those are most often due to a lack of knowledge, due to a problem with my measuring devices, due to a problem with access to data. And there are two kinds of errors which you find in literature. One is the so-called aleatory uncertainty, and the other one is the epistemic. Those would be random processes, random signals. So all of you who have studied stuff like technical stuff, they know about error propagation, and there are rather standardized processes for propagation of random errors. I don't deal with that here at all. Those would come in addition to what I'm going to talk about. Epistemic are data which are in principle accessible, however you don't have them. So it's, as I said before, if I know that I only get those data in 3 years from now, then, and I have to report now because I need to report today, then bad news, numbers are not there. So I need to deal with this. For epistemic uncertainty, I looked into potential sources, and what you find in literature is simply lack of data. So there are no data.
Darf ich Deutsch fragen?
Wie bitte?
Darf ich Deutsch
Ja, aber wegen meiner.
Aber, also, wenn Sie wissen, dass Sie falsch liegen,
Ja.
dass Sie falsche Daten produzieren,
Ja.
und können Sie dafür verklagen? Also
Nein.
Nein.
Nein. Nee. Ich habe die Daten einfach nicht. This is why when you write a report, make very explicit where you get data from. When you see a CO2 footprint, always look into these little letters that tell you where are data from. How precise are those? There was one article I found at some moment which I had fun with, because I always thought that I'm the only one who doesn't know. And then someone else reported that only about 10% of CO2 footprint reports report an error with the footprints. Now that is interesting. If the error is small, then that's nice, but if the error is significant, which I presumably have to say, then this is significant. Now, conversion factors, I already told you, can be a problem, because simply some companies don't have them, some don't want to share them. There's conflicting information you have no way to resolve. One I personally enjoy is the measurement systematics, the measurement errors. There has been a rather old study of the University of Twente who looked into Stromzähler, the electricity counter, who come out of wind turbines, and they found errors of up to 350%, which I loved. Usually, when you could run into errors with energy counters, the best one I find for practical use is gas counters, because what you actually buy when you gas is, German term would be Heizwert, so Brennwert, so the heat that you can generate with gas. That's what I pay you for if you deliver me gas. However, what I can measure at home is the volume and the temperature. Now, both of that, the volume has an effect on the temperature has an effect on the volume, as you know. Now, the burning value of gas in Bavaria, if you Googled, if you have fun with this, should be the same in Austria, can differ by about 7 to 8%, depending on which gas enters the local network. The error of the measuring device by law can range between 2 and 3%. You know, if you have errors, then usually you need to multiply them in order to get the total error. And then you have a temperature-dependent error, and the temperature, of course, determines the volume that you measure. So that adds to this for a little. Usually the temperature when something comes out of the earth should be around 7 degrees, randomly, but 2 to 3 degrees can make a difference. Yeah? So if you added all this, you end up in an error of about 12%. And what is astonishing is that, of course, you need to pay for not the error, but the absolute number. You can be 12% off with what you really get, and there's no way to sue the gas company for those. So this is why when I work with companies, I permanently give them the advice to measure temperature, volume accurately, and burn it in order to get the Heizwert, Brennwert. So it sounds trivial, but this is behind this here. Quantization errors you should be aware of is if you have a computer and it has 126 bits, then you always have an error of about 0.8% or so, because it's 1 divided by 126. Anyhow, so those would be the errors that you usually end up with, yeah?
Question here. So in your example, the problem with the measurement device, that there's some uncertainty and that the temperature measuring is uncertain, this definitely counts as measurement error. But the type of gas, since there is a gas that burns well and another type that doesn't burn so well, would that be also on a measurement error or on the lack of data or something else?
I would call it rather lack of data, and you're right when you correct that. However, the whole story for me goes under the headline is there's no way for you to know as a usual user. You just don't know. No one as a home user would invest that money. Even professional users don't have a clue, most of the times at least. Although if you think about a bigger company who has a gas bill of, I don't know, 30,000 euro per per month, then if you get 10% more or less for that, you should want to know. Most companies don't spend the effort for that, because in essence, most often the monetary value for a total company is too small. However, privately, I think it's worthwhile. Anyhow, I made a collection of data which I found did help me when I look at certain things, certain numbers. So for example, for gas, error of 2 to 6%. For liquids, 2 to 7%. So you're always off. What I'm trying to convince you of is when you get a carbon footprint out of literature, expect a minimum amount of error of around 10%. Randomly, anyone that says that he can do more precise for something a year ago, I would have strong doubts on. So I'm not trying to say I can do better, don't get me wrong. What I'm trying to say is, principally, you will not be significantly better than that. Okay, so in other words, lower than 5 to 8% I don't think is possible. Okay, so 2 examples, and I'm trying to be fast because I'm running out of time. This would be just a relative contribution one. This is a museum in Munich, Lehmbach House. Those of you who go to Munich, I would really recommend to go there if you are into certain parts of art. Actually, I'm an art collector. This is really good. Go there. The important part here is that you can tell is heating is important, electricity, and of course that the visitors can go there. So if they would like to save energy, 5% per year, this is where they have to look at. So independent of whether you have absolute numbers or relative number, you immediately know what to go for. Now for a newspaper, next one, I rescaled just to give you absolute numbers. Paper, about 10,000. Purchased electricity, 1,500. Offset ink, 1,500. The electricity transportation, about 200. 6%. You should be aware of when the electric resistance of wires has about 6% of energy consumption that it translates to. So you just be aware of energy consumption, energy transportation is not for free. However, without going into details, what you can immediately tell is you pick the big ones, because with the 10 tons contribution you can't do anything. You pick the big ones and then you start to work on it. That's the target measuring part. So this is where you work on. So I'm just skipping this one.
I have a question.
Go ahead.
With your 2 examples, you mentioned commute to the location.
Yes.
Or for the tourists for the museum.
Yes.
Does this include also public transportation, or is it?
Yes.
Okay.
Yes, they do
So any
statistics.
kind of
They do statistics on that. I'm not sure though how detailed this is. I did the numbers I didn't generate. I was once at a conference where those numbers were shown, and I asked them whether I could use those.
I was just wondering whether it's just the company-owned transports, or whether it's also every kind of transport to this.
It's not company owned. This is it's a museum. It's a public museum, and so any commute that takes you there. Okay. I already said that. Pick the big 7 if you want to reduce something, and then you look down here. So that's paper, indirect emissions, and so forth. So it's this list here, and then what you do is you approach suppliers. You ask them. Because you can't do anything about it. I buy your paper, so I will ask you, what are you doing to reduce your carbon footprint? And then I would anticipate in my prospective reduction for the next year. I also look for electricity. And by carbon neutral energy, that would give me about 10% reduction per year. I look at, for the transportation part, which you can tell is involving this, and this aspect. I will have to look for other ways to transport things. And then you reduce the amount of inks, because the ink would also have an influence, and then, well, you're trying to do whatever is possible. So this, in essence, is what you do in order to reduce a footprint. So it's not particularly smart. The calculation part is the difficult one. Now, what else can you do? And I assume that this list is on the website then, so I don't talk too much about this, but if you Google, there is a particularly good article by Konrad Luttrop, and it's called Luttrop's Golden Rules in Literature. If you Google Luttrop's Golden Rules, you find those, and he developed a list of 10 rules which he found most often being applied in order to reduce footprints. I'm just reproducing them, so you extend lifetime, you have no more toxic use, you have no compound material, as solid as possible materials. So all of those thoughts, which actually are pretty obvious if you think about it, they are used for his case. So those two slides. We don't need them right now because I'm not using them. Long lifetimes would, of course, translate to a lower carbon footprint per year. So it's logic, but he was naming all those. Now, for the digital newspaper one, I'm just trying to skip the analog newspaper. Again, we looked at the phases in lifetime, and I'm trying just to highlight two things. For this particular example, I had 300,000 analog readers and 300,000 digital readers. I don't bother you with numbers because of a lack of time. There are server farms involved, and there's a home using involved. Both of those, the server farm and the home using environment, would depend on the number of readers and the reading time. If I read longer, consequently, I use more electric energy. Also, be aware, the absolute contribution of the devices will also increase with the reading time. Usually, home appliances are used between 5 or 6 hours per day. And if you use your home computer for 5 hours for the one purpose, of course the relative contribution grows, while if you only used it for 1 hour, the relative contribution is lower. If you calculated those aspects for 35 and 40 minutes of reading for the server farm and for the home appliances, you find out that the total consumption, 35 minutes, 10,086,000 tons of carbon dioxide would be the relative contribution, as opposed to 17,000 tons for the analog newspaper. Same amount of readers. Now those are pretty impressive numbers, but bad news is the error on those numbers is significant because I have not found good data. The server farms, I only found one set of data for, which was by Öko-Institut in Freiburg. And the home appliances were not really available even to the newspaper vendor, so the publisher. They didn't know which type of computer, which cell phone, which tablet was being used. As a consequence, there could easily be a 50% error on those numbers. Even if that is the case, however, in total, this would be about 100,000 tons, which are consumed to access 300,000 readers for 35 minutes, as opposed to about 20,000 tons. Now, if 50% of error, I'm wrong, so my fault, I can't do anything about, I didn't have good data. Even if that would be 50,000, it would still be a factor 2 larger than the analog newspaper. So be alert, the statement that something digital is by definition cheaper, ecology-wise, than an analog product is not necessarily true. There is no way for you to tell. Data, however, are particularly difficult to get. So I'm trying to, and with all question marks, with all caveats, what I'm trying to say is that there is comparing literature. I found one article made in Sweden in the 2013, I think it was, but they came up with a break-even point of 13 minutes. So I'm here with 9 minutes. So I don't care, but be alert, a digital product, the assumption that digital production goes along without ecological cost is wrong. It's not self-explaining. Well, I just skipped this, I already mentioned that. I wanted to shortly spend some time on individual footprints because those are calculated different. Now, what is usually done is an approach called consumption land use matrix, and that is very comparable to the economic input-output approach. In essence, that approach splits 3 different sources of emissions. One is stuff you emit at home for short-lived goods. It's like food, clothing, stuff like this. Short-term consumption, for example, in the public world, schools, streets, electricity for street lighting. Third, long-term consumption, buildings, roads, machinery, stuff that has a very long lifetime. In essence, what comes out is that this list here refers to short-lasting consumption, and this is done on a worldwide scale. On a worldwide, what you see is leisure, 4.5%, alcohol, about 4%. So it's rather significant if you just looked into this line here. Short-lasting public consumption, about 9%, long-lasting consumption, about 16%. This section here has to be read the other way around. The sun delivers, and Earth, heat of the Earth, totally delivered about 2.7 tons per year. If I split this accordingly to the total percentages, that would lead to about 0.4 tons of consumption, which are available for us, which we could use for that purpose. About 0.2 tons for short-lasting, about 2.1 tons for short-lasting consumptions at home. So that would be the logic. So what the Earth gives me, what the sun gives me, that I can consume individually. I cannot consume more in total than 2.7 tons. Any one of you having idea what the usual European consumes per year? Anyone? Just random number. So in Europe, it's about 10 tons per year. So it's a factor of 5. In Austria especially, it's 8.4 tons. So you guys, I'm not finger pointing apparently, you consume more than you have. So what to do about this? Trying to skip a couple of things. So that would be the total consumption today, 8.2 tons. Austria, car, about 1.9 tons. Heating, 3.1. Meat, be alert, significant. You fly to Greece once per year. I'm not sure, I've never been in Greece. And you have about 100 bathtubs. So that would be about sorry to reduce you to that. And you could do different measures. You could consciously use your energy. You could use your energy more efficiently. Heating, mobility by a car that uses less energy, and so forth. By the way, an interesting one, I have not found data on how to relatively weight. If you have a working car that's still operating, safe, working, and you put this away, you just throw it away, demolish it, and you buy a new car instead, where would the balance be? Because building a car must be economically less attractive than buying a new electric car. So there must be a balance somewhere, but I don't know where. I have not found any information. Anyhow, so there's a number of measures, but then look at your options. You could use an electric car. That would take you down about a bit more than a factor of 2, actually 2.5 or so. You could isolate your house better. You could use vegan food, which would be very helpful. You could also go by train to Greece or stay at home. And you could shower instead. Now that would take you into the limits of what is available to you. Now, the reason for me to state this is not to argue about individual numbers, but there's a message here, and that I find really important. If someone tells you that saving CO2 kills your economy, kills your social environment, makes you dead all over, this is simply overstated. Because you can survive like this. Even more, your whole culture can operate like this. So that's not a reason to state for any one of us, we cannot live like this. We can live like this without any problem. I find it more important than to look at the absolute numbers, to look at this message, is be alert. We can easily survive with our economic systems in a structure like this.
Sorry, I have a question, but this is now only my individual.
Yes.
What about in Austria, where has a lot of infrastructure, like hospitals?
This is why I was referring from a methodology point of view. This is the economic input-output approach. That tells me that you have about 2.1 tons available for that purpose. And the number tells me you could, without reducing your lifestyle, you could get about the same as what you can actually use, you're permitted to use. Provided, of course, that the other two sources we mentioned also stay within their boundaries. So this is why I mentioned the absolute numbers. The absolute numbers I calculated was 1.9 and 2.1 you have available. So yes, you could stay within this limit. Wurde das klar? Was ich eben versucht habe zu sagen war, ich habe ein Beispiel genommen, wo stehen Sie heute? Ich habe Ihnen gezeigt, Sie könnten mit weniger Energie zurechtkommen und habe einen Fall ausgerechnet, wo 1,9 Tonnen rauskommen. Wenn ich diese Art zu rechnen nehme, komme ich darauf, dass Sie für diesen Rechnungsposten 2,1 Tonnen hätten. Tatsächlich haben Sie aber nur 1,9 Tonnen genutzt und folglich sind Sie da innerhalb der Grenze mit Ihrer Frage, die erlaubt wäre. Das heißt, das ginge, ohne dass man wie so allgemein beschworen sagt, die Wirtschaft bricht jetzt zusammen und wir sind alle tot. Sind wir nicht. Ist es?
Mir geht es nur darum, dass wir in Österreich oder in Europa so leben, dass wir sozusagen so allgemeine Infrastruktur, die wir nutzen, ja auch
Die steckt hier unten drin. Die steckt in den beiden Rechnungsposten. Das hatte ich Ihnen eingangs gesagt. Ich gehe nochmal einen zurück. Is that clear what we're talking about? Kind of. She was asking where if in this calculation where public comes into place, and how if I reduce the one number, the other number would also be reduced. Die Liste teilt sich in 3 Themen auf. Das eine ist allgemein, was ich privat verbrauche. Das hier ist staatlicher Verbrauch und das hier ist sehr langfristiger Energieverbrauch. Ich habe nur diese Liste gefunden und ich habe nur den kalkuliert.
Nein, das ist mal dran. Wie kommt das noch zu wenig vor? Das habe ich
Dann kann ich habe Literaturdaten genommen an der Stelle von Scientists for Future in Wien. Und ich kann Ihnen nicht kommentieren, ob das zu wenig ist. Die 2,1 Tonnen, die 2,7 Tonnen, die sind fix. Man weiß, wie hoch ist die Solarkonstante und man weiß, welche Wärme man aus der Erde rausziehen könnte. Die beiden Zahlen kennt man. Was hier nicht Berücksichtigung gefunden hat, war eher, dass sie bestimmte Rohstoffe nur beschränkt haben. Da an der Stelle, aber wir reden hier nur von CO2-Fußabdrücken. Es war nur die CO2-Aspekt, den wir besprechen. Sie fragen jetzt nicht so, dass ich antworten könnte. Was ich übersprungen habe, und vielleicht sollten wir doch eingehen ein bisschen darauf, wenn Sie im Internet CO2-Fußabdrucksrechner für Ihren Heimanwendung nehmen, dann basieren die in der Regel auf diesem CLUM-Approach, if you find data in the internet on personal CO2 consumption, most often this is the approach that people are using. They ask you for how often do you do this? What's your mobility consumption? How far does your car go? How many square meters do you have? It's rather typical for this. So you get a set of questions that most often looks like this, or this is at least the introduction. And then all of a sudden, so you enter this, and then it says, thank you, nature, and be alert. I don't know about this particular site, however, be alert. Often they ask you for donations, and the qualification of those data, I would generally argue. So I wouldn't say that this particular source is wrong, but I would say that there is reason to be alert for a wrong used number, and I was trying to convince you early that even in professional databases, there may be errors. So you are charged for something which may not really have the value that you think. I was going kind of fast at the very end. However, what I wanted to say at the end is that currently the average number for Europe, as I said, is 10 point something tons. Austria is slightly slightly lower. What the Earth can deliver is about 2.7 tons. However, you can get you can achieve the respective savings without killing yourself or without risking that you can survive. I think I'll leave it like this for the moment. So what we did is we talked a little about law, we talked a little about the Sustainability Development Goals, we talked about errors and how to calculate footprints. We talked a little about reduction of footprints. Remember the big 7 in industry, however the same more or less as in private households. And we talked quite a bit about the non-financial reporting, which leads to quite some effect for economy. And we use 2 calculation methods, the one based on ISO and the economic input-output approach. I think we should about leave it like this for the moment. How long do we still have?
Fine for having a discussion.
Okay? Then, do you have any further questions?
Thank you.
Thank you.